Ever wondered what makes up the mysterious rings around Uranus, the seventh planet from the Sun? As we journey through the cosmos, it's fascinating to delve into the composition of these elusive rings. Unlike the grandeur of Saturn's rings, those encircling Uranus have a more subtle allure. They're dark and narrow, a stark contrast to Saturn's wide and brilliant bands. So what makes up these rings? The answer might surprise you. These rings primarily consist of small particles. We're talking about dust, rocks, and even organic materials. Yes, you heard that right, organic materials. These particles coalesce to form the dark, narrow rings that encircle Uranus. They may not have the same visual impact as Saturn's rings, but their unique composition tells a rich, compelling story about the planet they orbit. So, unlike the bright and grand rings of Saturn, Uranus sports dark, narrow rings primarily composed of dust, rocks, and organic materials. It's an intriguing contrast, wouldn't you agree? Now that we know what the rings are made of, how do they behave and structure themselves around the tilted giant? Well, the rings of Uranus are not as bright as Saturn's, making them faint and more challenging to observe from our home planet. They are classified into two main categories: outer rings and inner rings. Some of these rings even show complex structures contributing to the overall mystique of this distant planet. But what makes these rings truly unique is their relationship with Uranus. You see, Uranus has an extreme tilt, unlike any other planet in our solar system. Interestingly, the rings orbit in the same inclined plane as the planet, mirroring its distinctive tilt. This creates a one-of-a-kind observational phenomenon from Earth. It's like watching a cosmic dance viewed from a tilted stage. In essence, the rings of Uranus, faint and challenging to observe, reflect the unique tilt of the planet, creating an intriguing observational phenomenon from Earth. But how did these rings come into existence, and why should we care? This question takes us back to the prevailing theory, which suggests that Uranus's rings were born from the catastrophic breakup of smaller moons. Imagine asteroids or comets colliding with these moons, causing them to shatter into countless pieces. These fragments then scattered and became trapped in orbits around the planet, forming the rings we see today. So why are these rings so important? Well, they serve as a looking glass into the past, allowing us to understand the dynamics and history of planetary ring systems. By studying Uranus's rings, we can glean insights into the impacts and collisions that have shaped this region of our solar system. Furthermore, the interaction between the rings, the moons, and Uranus's magnetic field is a key area of research, shedding light on the evolution of the ring system and the influence of the planet's tilt. To sum up, the rings of Uranus, subtle as they may appear, are intriguing elements that not only reveal the history and dynamics of planetary ring systems, but also contribute to our overall understanding of the formation and evolution of giant planets in our solar system.